we now know how to compute the atomic mass and atomic number, we shall now proceed in understanding the isotopes and writing the isotopic symbol. But first, let us recall what is isotopes all about. So isotopes basically is you have the same element, but you have different number of neutrons. That tells you also that you have different number of mass, which is also practically saying you have the same number of atomic number. So technically, the differences is just only the number of neutrons, which tells you about the number also of the mass. So let's proceed here. We have to write the isotopic symbol of gallium that has 37 neutrons, and we have here another one which is having a 39 neutron. So we just create a table for us to distinguish what will be the isotopic symbol, for us to know what also the atomic mass and the given atomic number. So this will give us an idea how we're going to write the isotopic symbol of this element that has the following given using 37 neutrons and 39 neutrons respectively. So let's write first 37 neutrons here. That will be in the first given. So to know what will be the letter or the subscript C, which corresponds to atomic number, we shall use the periodic table that we have to know what will be the atomic number of gallium. So let's find what's the atomic number of gallium. So here it is. We have 31. So we just write here 31. Okay. And to know what will be the atomic mass of this, we just follow the reversibility of the A minus. So instead, we shall proceed in adding these two, okay, which is the subscript that corresponds to atomic mass and the number of neutrons. So that will be 31 plus 37. So let's rewrite here in letter A. So 31, which corresponds the number of proton, because again, the number of proton is equals the number of electron. We shall add it with 37. Then 31 plus 37, that will constitute as to the answer of 68. Okay? So if you're going to have it in the other side, that tells you also 68 minus 31, you get 37. Which is, that means you have 37 neutrons for this particular isotope. So that also we get 68 mass and 37 as sure neutrons and 31 as sure atomic number. So later on we will write it in the isotopic symbol. Let's just solve for the next given. So let's write here another given, 39. So the 39 will be our point of reference or our guide. So again, since we have the same isotopic symbol for gallium, the same element only, we will just write 31 instead. So 31 is our atomic number for gallium. So the same thing, we're just going to get the reversibility of operation. We're just going to add. Okay, so let's add 31 rather, plus 39. So the atomic number of gallium plus the number of neutrons, which is 39, it is equals to 70. So you get the mass for this second given, which is 70. Now, to check, you can use A minus C. So 70 minus 31, we get 39. Given. So we just stick with the atomic number, which is 31 for the gallium. So how we're going to rewrite that one? Let's proceed in rewriting. So in this case, we're going to rewrite for the first given, we're going to rewrite for Ga you have to write the letter A, which corresponds to the atomic mass. That will be 68, and then we will follow by atomic number, which is 21. For the next one, we will have the same gallium. So we will just take the mass number of 70, and then we just use again the atomic number of 31. So here we get the isotopic symbol for the first given, having 37 neutrons, we have 68, 31 value, and for the 39 neutrons, we have 70 and 31 value.